Hey everyone. Thank you all for coming today, especially after that game-changing keynote that we just have, and everyone is just trying to assimilate everything that we have just heard. And thank you for coming here, hearing a little bit about cutting costs, not performance. So let me start by asking you a question. How many of you have ever been asked, why are my data pipelines costing so much money? Or how much money is a specific data process costing? Or how much money are we investing on this specific business unit to give them their data? And it's difficult to answer these questions, right? My goal today is to help you a little bit on this. So let me start by introducing myself. My name is Pedro Ferreira. I'm project manager in NTT DATA, Portugal. I'm actually the practice lead in Databricks. And during the last few years, I had the chance to follow up really closely most of our Databricks projects, not only in Portugal, but also some of them in other geographies. Okay? And based on that experience, I built this presentation. In addition, last year, we had a project, a really interesting one, that the goal was exactly this one, cutting costs. And based on that project and with a close relationship with Databricks, I also was invited for the champion program. And a few months ago, I had the honor to be recognized as Solutions Architect Champion. So what are we talking about today? So first of all, we will cover some of the most common challenges that we face on almost every organizations. Also, I will share with you some of the best practices that you can take in consideration while facing these issues. And at last, I will also try to share with you some real-world use cases that we found throughout our projects to show you that, and to show you the real impact that these things may have. Okay? But my main goal is not just to share this with you. My main goal is to plant a seed in you and for you to go back to your organizations and challenge your teams, challenge your data architects, challenge everyone to cut the costs. So let me start with one sentence. Meaningful cost reduction begins when your platform aligns precisely with business reality. And to be honest, when I was preparing for this presentation, I shared this with a colleague of mine, and he told me, Peter, that's trivial. Everybody knows that. But can you really say that all your organizations all your data platforms are 100% aligned with the business reality, business requirements that they have? And I think this is the main question that we have to answer. So let's now start to dive a little bit technical. And let's all start talking a little bit about how Databricks costs work, right? So Databricks, it's pretty much, they are pretty much divided into areas. DBUs, that is actually the cost of you using Databricks, right? And the cost related to infrastructure. That's actually the cost that you pay for renting all the infrastructure to your cloud provider. And there are some other concepts that I want to introduce to ensure that we will all be on the same page throughout the rest of the presentation. The first of one, Databricks is pay as you go. And this one is a concept that I want you all to keep in your mind because I will bring it back a few times during the presentation. The other one is that you can actually pre-purchase some DBU. So you can pre-purchase the Databricks units that you have. And by committing to that usage, you end up saving some money on those DBUs. Well, if you can save on pre-purchasing DBUs, you can also do it by infrastructure. And that's actually the reserved instances that you can do with your cloud provider. And in addition, there is also spot instances. Spot instances are just machines, virtual machines. They are out there. They're not being used. And the cloud providers enables you to use them for a fraction of the price. However, there is a catch. They may need it, and the process may fail. But what I challenge you to think on these situations is, I mean, could you what would be the impact if the process failed? Aren't there some process that you can just put it on a machine? It runs, for example, every minute, or it has a really nice retry policies that ensures that it won't affect your pipelines? In a lot of them, you can. So let's start to addressing one of the main issues when we see the cost on a platform. And the main issue is, for what we see out there, there are a lot of data engineers that they don't know how to choose the right compute. I mean, most data engineers, they focus on the pipelines, but for what we see out there, most of them, they end up choosing the same compute that the other processes are already using on the data platform, or just overloading everything to the same cluster that there is. And they don't really wait for a second and try to think about which one could be the best. So this list is pretty much the one that we use to try to decide the most proper one. So let's start talking about job clusters and all-purpose clusters. And in fact, just to introduce you a little bit about the difference, job clusters are ephemeral, meaning that they are attached to a job, and when the job ends, the cluster also stops. You are not paying for any more than that. Actually, Databricks will advise you to, and always advise you to use these ones in production, because they are, you have the insurance that the clusters are not idle. They are not just there waiting for something to be run. And they are also isolated, meaning that they won't be impacted for some other process that may have a peak on the data that it's arriving and may have an impact on a critical process that you may have running at the same time. On the other end, all-purpose clusters, they were designed to be interactive. I mean, these are the clusters that probably most of your teams are using on their notebooks to do their developments or on their day-to-day. And my message in here, and it's pretty much, if you can automatize it, move it to job clusters. There is one thing that it's also good to take in consideration on this. Actually, the cost on DBUs on job clusters is smaller than on all-purpose clusters. The other thing that we also take in consideration is the uses of spot instances and reserve instances. I mean, I just introduced you the terms, but like I said in the beginning, most teams use always the same clusters, right? And if you are using the same clusters, meaning, I mean, that's actually, you are using the same virtual machines. So why don't you go back to your cloud provider and commit with a number of machines that you will use for a year? You don't have to be aggressive. You don't have to commit to use another % of the machines that you used last year. You can have a different approach and start by 20%. But I'm sure that if you were able to save at least 5% on these, or only 5% on these on the cost of your data platform, that would be huge. The other one that we also take in consideration is Photon, the usage of Photon. And I know that Photon by itself, it's more expensive. The price of the DBUs are higher. But remember when I said before, for you to keep in mind, pay as you go? In fact, Photon, and if you check Databricks documentation and some studies, with Photon, most of your process will be faster. So my message in here is try it. I mean, if there is a small chance that your process will run faster and you'll end up saving money with Photon, why not? Worst case scenario, it will be like 1 day or 2 days that the cost will be a bit higher, but you can measure exactly how much higher it can be. And best case scenario, you'll end up save a lot of money. In fact, this was what we did in one of our projects, that just by applying these strategies, we were able to reduce up to 50% on the DBU count and DBU costs on a data platform. This was basically, this organization had a different orchestration tool. They were not using Databricks jobs, and they had a huge cluster to compute everything every single day. The thing is, they needed a large cluster for the data ingestion and most of the data of the initial data pipelines, but for the rest of the day, a simpler cluster would be enough. And just by moving these to jobs in Databricks, the other orchestration tool was still being used to trigger these jobs. But just by moving everything to Databricks jobs, instead of having that huge cluster that I was telling you about, having smaller clusters to do most of the pipeline, and only have this big cluster up and running for like a small portion of the time, this was game-changing for these guys. And we didn't did just this. I mean, we also had to, like I just was saying, we had to pick the right instance types. So in Databricks, you have different types of virtual machines that you can opt, right? You have memory optimize, compute optimize, storage optimize. You even have GPU clusters that you can, or GPU machines that you can opt mainly for your AI workloads. And just the fact that sometimes you can check what you are actually doing on your processes and wonder which can be the best cluster for that process, it's huge. I mean, the impact it will be, sometimes these machines are a bit more expensive than the ones that are not optimized. But again, if you can run the same thing much faster, you'll then save money. Also, it's important to take in consideration the cluster sizing, meaning the number of nodes, the size of the machines, the amount of memory that machine will have. And in fact, my best suggestion in here is start with a small cluster and monitor everything. Check if you need to increase. I mean, you know your processes. You know the clusters that you are using. If you don't know if you'll be able to reduce to a smaller one, check the metrics that you have. You have Spark UI and now the metrics in Databricks. The UI is completely different from, I think, a few months ago. And it's much easier to understand and to monitor all these things in the cluster. So I challenge you to check it out. And if needed, or if you feel that it would be appropriate, just get the cluster to a smaller one. And I mean, there's also auto-scaling and auto-termination. And auto-scaling, sometimes when I'm checking one of our clients' data platform, I see that sometimes they have the number of workers and fixed. And why are they doing that? I mean, most times you can start with 1 or 2 workers and then let it auto-scale to the number that you think that it may be required throughout your data pipeline. Mainly when we are talking about development environments. I mean, sometimes when I check the development environment of a client, they have a huge cluster in there. I mean, that's not actually being used most of the time. And my other suggestion is to be aggressive on auto-termination. I mean, what's the worst case scenario that can happen? Most, like I said before, if it's in production, my advice is to go with job clusters. If you are using all-purpose clusters, if you set an aggressive auto-termination, meaning in development, if no one is using the cluster will die. If your data team is working, if they continue work, the cluster will be there up and running all the time. But if for some reason they stop working for 30 minutes, 40 minutes, 15 minutes, they don't run anything on the cluster, it will die, and it will take 5 to 6 minutes to spin it again. And let me give you one example on this. Imagine that you have 2 hours on auto-termination. And it's a number that I've seen quite often. Imagine that your data team is working at 6 p.m., everyone leaves. There is one guy, one of your data engineers, that he had a query that stuck in his mind. When he arrives home, 7:30 more or less, he opens Databricks, he tries to run the query, it worked, close the computer, and continues the next day. If everyone stopped working at 6 p.m., the cluster, if it has an auto-termination time of 2 hours, it will stay up until 8 p.m., just idle. And if someone did something at 7:30, this window will grow until 9:30, meaning that just on this day, you end up paying 3.5 hours more for nothing. The other thing that we also suggest to take in consideration is the use of SQL warehouses. I mean, you saw in the keynote, the performance on these ones, it's huge. I know that they are a bit more expensive, but they were designed to be used for BI and analytics. They have Photon and predictive I/O enabled in most of them. And I mean, it's, if you have something connected with a Power BI, or if you have some of these, Power BI or any other BI tool, or if you have some of these analytics and BI workloads, that it's pretty much SQL that everyone is doing there, why don't you try to check the SQL warehouses? And at last, the serverless compute. And the serverless, I mean, for most of the sessions that I've seen throughout this event and some of the conversations that I had, I feel that we'll have to be quite, we'll hear the name of the word serverless quite often. Because, I mean, you saw on the keynote, if you want to just to call an API, I mean, call it with a serverless. You don't have to spin up a cluster that will take 5 to 6 minutes, call an API, and just for a thing that may last just a few seconds. Another example on this, and it was actually when we end up saving up to 30% on the costs, actually on the cost of SQL warehouses, was by enabling serverless on the communications with Power BI. Because on this case, we end up having to have all our clusters up and running at least 8 hours a day. If a user wake up in the middle of the night, couldn't sleep, you really wanted to check their Power BI, it would take 6 to 5 minutes to start. We would receive an incident that day, so everyone would arrive in the morning, there is an incident, no one happened, there is nothing there. It was just the machine that took a while to spin up. And just by moving to serverless, we could ensure that we were not receiving these tickets anymore. We ensured that everyone could use their dashboards anytime they wanted. And we ensured that we were no over-provisioning anymore. In the end, we had the business unit happy. We had everything running faster than before, and everything actually cheaper. So win-win-win. There is also something that, I was talking about compute, and we were always, probably most of us were on the keynote, and we were hearing about data life tables as well, or lake flow declarative pipelines, if I'm not wrong. And on those, my main suggestion for you is try to understand exactly what they are doing. What are the requirements that you have when you are spinning up them? Because at least at this moment, you have three types of data life tables: the cores, the advanced, and the pro. And in some of them, it's basically CDC, then data quality. And if you are not using the full capacity of those DLTs, and sometimes it's quite difficult, I've seen some clients losing a lot of money because they were not cautious when they spin these DLTs or any serverless pipeline, because it starts auto-scaling and sometimes it starts to control it. If you know exactly what you need, just provide those needs to your data platform. Don't try to think, what if I need it in the future? If you need it in the future, you just change the kind of the machines that you have. It's as easy as that. Actually, like I said before, in the beginning, one of the biggest challenges that we have is to be able to answer those questions that we all had of why is this costing so much money? How much money are we investing on a specific data pipeline, or how much money are we wasting on, or is this costing? And this leads me to one of the main things that I suggest you all to do, that governs all the costs of your data platform. And the main thing, the first suggestion that I have there, it's actually something that you can do to ensure that your data teams, mainly the most junior data engineers, they don't just choose a random cluster and they use it every time. It's enforced cluster policies. I mean, if your data team does not need a huge cluster, don't let them create one. If they want to create one, they can talk with you, or they can talk with someone in charge, and they can create another cluster policy for that. The other one, and this one, I could have created a slide just for this one, is tags. Because if you want to monitor, you can only monitor based on tags. You can only filter based on tags, right? You can see everything together, but if you don't tag, you won't be able to divide those dashboards and to check and to split everything and to identify exactly how much money the data process that is trying to identify new leads is costing me. So tag everything. Tags, you don't pay for tags. What's the worst case scenario? Creating so much tags that you don't even know what's there, right? And the next one is actually related with Unity Catalog. That, we just saw that 97% of the companies use it. So, and it's to use the system tables. Because the system tables, they have the billing tables that allows you to check exactly how much DBUs you are using. But it's not just the billing tables that I'm advising you to use. It's actually also the audit ones and the usage ones. So you can also check if your tables are being used or not. And I mean, we see quite often, and I think in all organizations this happens, then a business unit asks the technical team, I need this table, I need this process, I need something. The engineering team creates it, it's there, and sometimes they are not. They use it for 1 or 2 months, and then they stop using it, and they don't say anything to anyone. It's just there. We are wasting a lot of money to have those processes running and the data updated, but no one using that. And with system tables, you can actually check if the table is being used or not. If it's not, go back to the business unit and ask them, can I delete this or not? The other one is dashboards and alerts. So build the dashboards around this. Actually, if you are using Unity Catalog, I mean, you can create a dashboard related with your costs in just a few clicks. And the dashboard is quite good. It's quite complete. And I mean, it's just as easy as that. We all know that Databricks does not work just by itself. It needs some other things. So it needs the rest of the infrastructure. So it needs storage. And in here, I mean, after all the sessions that we have heard, Delta Lake should also be there. It's Delta Lake and Delta Format or Iceberg, right? We all heard about it, same optimizations. And my suggestion in here is, if you can, use managed tables. I know that some organizations, for numerous reasons, you cannot move to managed tables. You have to use external ones. But even on those, ensure that you have your regular optimizers and vacuums set to ensure that you don't have data that is not used anymore stored on your storage account. And if you use managed tables, I mean, use predictive optimization. It will optimize everything for you. The other thing that I want you to take in consideration, and this one is not only inside Databricks, it's actually related with also the cloud provider that you may have, is the usage of data lifecycle policies. Because, as you know, usually the cloud providers, they have different kinds of storage, different tiers. So there is a most expensive one, a most expensive storage, but cheaper read and writes. And there are some other tiers that's exactly the opposite. So you'd pay almost nothing for the storage, but you pay a lot for reading and writing for that tier. And there was a project that we had that we were able to identify that the vacuums were happening only after the data was moved to a cooler tier, meaning that we were moving the data from a place that it's actually cheaper to read and write to a place that the storage is cheaper, but only a few days later, we would go there and delete that data. Actually, on this case, when we moved to this second tier of data, we had to rent and commit for at least 30 days of the data. If we remove the data prior to that period, we would have to pay the entire period as well. So on this case, just by ensuring that everything was aligned, we were able to save all that money. But this one that's right here, that's a reduction of 75% of the costs, was just by applying regular vacuums. I mean, we entered in a project that they were not vacuuming their tables, meaning that all the chances that they have done throughout the entire life of that data platform, all the Parquet files were still there. They didn't add deleting vectors, so I mean, Parquet is immutable, so all the files were there. In addition, Databricks also needs network. And in here, I know that this slide, it has a lot of information. But my main idea in here and my biggest goal is to ensure that you understand the different connections that may be happening in here. And also to share with you which of these connections they have the biggest amount of data going through. Because between users and application and Databricks account, most organizations want to ensure that it's contained and only people in the right networks can access it. And actually, there is not a huge throughput in there. There is low data that's going through that connection. But imagine that you have a private link or private endpoint between the connection, on the connection 4, between your clusters and your storage. All the time that you will try to access or to run a query or to access your tables, you'll have to pay for that connection. And for some organization, that is a requirement. But if on your organization that's not a requirement and you are actually doing that, because sometimes on the process that I'm using here as an example, we saw this connection was built in a way that we were paying for using this network. And just by changing the configuration, we were able to save 20% not only on networking, but on the entire data platform costs. Imagine if you could save 20% of your data platform. I think no one would say no, right? With Unity Catalog and the way that Unity Catalog manages the connections with the access connectors, this architecture is a bit easier to manage. Before we had some other challenges, but now it's a bit easier. So what do I want you to keep in mind? And like I said, go back to your organizations and challenge your teams. So reassess workloads and justify costs. I mean, regularly. Check it again. If you see that some pipeline is not being used, if some pipeline, the cost of that specific pipeline is increasing a lot, ask your teams why. When I was a data engineer, I hated these questions because, I mean, all the process can be improved and all the process can be optimized. And people often, they don't like for when you check when you ask and question the process that are running. But it's a work that has to be done, right? And people don't say that I was the one who advised you to go there. So choose also the right size and optimize your compute. It will be critical. It's one of the biggest source of costs on your data platform. Also tag everything and track everything. And just because it's not on DBUs, don't overlook storage and networking. So that was a lot. If you have any questions, feel free. Don't forget to complete the survey. And thank you. Thank you all for coming.